Hi, everyone. One of the final types of models that we're going to be thinking about when we consider atoms is what we call the Bohr and Lewis diagram. Now, we'll get to Lewis in another day or so, but Bohr is going to be our focus. Notice that this word isn't spelled like just a Bohr, like B-O-R-E, but rather B-O-H-R. That's a gentleman's name, which I've brought up in class before. He actually has an element named after him, too. His name is Niels Bohr. He's a Danish scientist or chemist. Maybe you've heard of him, maybe you haven't. He was actually approached by Robert Oppenheimer, which a name might sound familiar to you, to work on the Manhattan Project, which was the project to develop the United States' first atomic bomb. He makes an appearance in that graphic novel I mentioned a while back called Trinity, the Story of the First Atomic Bomb. He is particularly famous because of how he was able to model and think about atoms at obviously a small scale. The picture that you see in the background, besides himself, is the little atom, which that blue dot in the middle, meaning the nucleus, and these rings or shells around the outside. That's what we call a Bohr model. If you're curious what his element is, his happens to be element 107 by the symbol of BH. So this is what he looks like when he's quite a bit older. I'll come back to this periodic table later because it's pretty neat. It's interactive. So make sure today that you're on page 20 with me in your chapter 1 Interactions of Matter packet. Your goal today is to be able to draw a Bohr model for the first 20 elements. Now, when I say first 20, I'm simply saying the elements that go from atomic number 1 through 20, that being hydrogen all the way down through calcium, which is the atomic number 20. The reason we're just doing the first 20 is because after the first 20, the breakdown of how the electrons are organized changes, which you will see in a little bit. Okay, back to our Bohr models. I kind of read through the objective and what I was going to do here. Let's look underneath background on Bohr's model. So Bohr, a major scientist in the development of the atomic theory, believed that electrons move around the nucleus. Remember, the nucleus is the central part of our atom, which is, in this picture, this black central dot. They move around the nucleus in energy levels, or shells. So each one of these circles here is an electron shell. You may hear in the future, there's another word that these shells are called. Sometimes you'll hear orbitals, but we're going to use the word shells. So each energy level, or shell, can hold a certain number of electrons. So just kind of roll with me here. I know it sounds a little abstract, but it'll kind of make more sense the more we practice. So the first shell, right here, can hold 2. So the first shell is this one right here. That's the first shell. Not this inner circle. This is the nucleus. We don't worry about that one. Okay, so that central part, always the nucleus. So the order goes 2, 8, 8, 8. Okay, so shells from the third level can, and beyond, can hold more electrons. As you might recall from the atomic theory lesson, the third can hold up to 18, and the fourth can hold up to 32. However, since the electrons start to fill up in a slightly different order, once we pass element 20, we only need to remember that 8 electrons is our maximum on these shells. If you're a little confused right now, don't worry. Let's practice. Let's go to page 21. And you're also going to need your periodic table, which I'm hoping you can kind of flip back and forth to. If you don't want to use that table, if you don't feel like flipping back and forth, you can just look up a periodic table online, but it's important that it has the atomic mass and the atomic number and the symbol written in that table too. I recommend just using your own periodic table. Okay, first steps. We got to find out how many protons, electrons, and neutrons are in aluminum. So when we look at our periodic table, actually got mine right here. Let's find aluminum, which is right here. It has the atomic number, you're thinking 13. You'd be right. So that's what we're going to record. Here we have 13 protons. The atomic number tells us how many protons and how many electrons there are in any given element. So these two numbers are always going to be the same. Not neutrons, though. That number is going to be different than our proton and electron amount. It's a very simple way to find this out. So to find neutrons, what we have to look at is the atomic mass. The atomic mass, which is right here, this big decimal number. Some of them have decimals, some don't. Before you do any calculations, round that number to the nearest whole number, which I know you're thinking in this case would be 27. Okay, because that 0.9 would round that up. Let's say if we happen to be doing carbon, what would you round that to? You'd round that to 12. Okay, if the number, let's say there's a number that would happen to be like 13.4, you're like, what does that go to? That would go to 13. What if this was instead 13.5? We'd round that to 14. Okay, so kind of 5 is the key to rounding up, 4 is the key to rounding down. But I know you know that. Okay, so 27 is the number we're going to keep in mind. So what we have to do is we subtract our atomic mass number from our atomic number. Okay, I want to give you a moment. I know in your heads you're thinking, all right, what is 27 minus 13? And you're thinking, oh, I know that, that's 14. That's the number of neutrons we now have. Subtract those two, and that gives us the number of neutrons. You'll follow that same step for every single element I ask you about. Okay, that's step one. Number two, the small circle represents the nucleus. So you're thinking, well, what's the small circle? Remember, that's what I was talking about back here, this central one. And we're going to pretend that this is our central circle. We're going to write how many protons, that's what the P stands for, and also how many neutrons we have there. So for aluminum, we know we have 13. That's from up here. And neutrons, which is 14. So there's our nucleus. Proton amount, neutron amount. Let's go to 3. There are, how many electrons we have again? We have 13. It's just a little fill-in-the-blank practice. 13 electrons in an aluminum atom. Electrons travel around the nucleus in layers called shells. The first shell can hold up to 2. This is a repeat from before. So we're going to fill in the protons and neutrons the same as we did number 2. So we're just doing building on steps here. 13, 14. Now we have to put 2 electrons in the first shell. Now, how to do this, you don't draw anything on this line here. Okay, that's our nucleus. We don't do anything there. We draw our electrons as little as large dots. And here, you'll notice that there's a pattern that I use to place the dots in. I usually go top to bottom, left to right, and kind of repeat those steps. That way, when we do add more shells, it's easier for me to count them, because counting the number of electrons will tell me what the identity of that element is. Next thing, how many electrons are left? You're like, what's that asking? So I've already placed 2 electrons down. So if I think about my total amount of electrons that I had to start with, I had 13, right? And I've used 2. So that means that I have 11 left to place. Let's put 11 left in that box. Okay, and that'll be the same thing for number 4. There should be 11 left. The second shell can hold up to 8 electrons. So you're thinking, well, why can't I just place more on here? Why can't I place all 13? Well, according to Bohr's models and his studies, electrons, so many, can only exist in certain shells, in certain numbers. So once you're at that cap for the shell, we can't add any more. We have to go to the next shell outside of it, like peeling off layers of an onion. Okay, so we're going to repeat what we did for this next step down here. Okay, 13 protons, 14 neutrons. And I'm going to redraw my first shell. I had 1 electron here, 1 electron here. Now in my second shell, or this is my new one right here that's been added, how many can I add? I can add 8. It goes 2, 8, 8, 8. So here's how I fill mine in. I go from top to bottom, so there's 2, left to right, And again, if you think, oh, how many do I have so far? So I have 4 there. I need 4 more in that second shell. So I'm trying to do this as neatly as I can. Take your time. You can always just recount it at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've used up 10. So I had 13 remain at the start. I used 10. I have 3 left. So my last shell can hold up to 8. So there are only 3 left though. So we're going to place those 3 in the last shell. So we're going to fill in the nucleus the same way we did number 2, so just repeat all of those steps from before. Protons, 13. And what I would do is I'd maybe pause the video, fill all your diagram in, and then play it through to see if you got it right. And I'm thinking most of you will do just fine. And I may not always ask you to write in how many protons, how many neutrons there are. I may just show a nucleus as a solid dot, like on that first page. Okay, so remember how the order goes: 2, 8, 8. And then we can fit 8 into the final third shell, but we're not going to need that many. Oops, I like starting top to bottom. Be careful that you're not accidentally filling in electrons in a different shell. And I always like, while I'm writing these circles, because I'm counting in my head the amount of electrons that I've placed down. So far I have 10, because I just duplicated what I did in this drawing right up here. Now we're on to our third shell. We've used up that shell, and we have 3 more to place right here. But we're not going to need to fill them all up, so I'm just going to go 1, 2, 3. Have I used up all 13 electrons? Yes, I have. So this is what your completed Bohr model for aluminum will look like. Another important reason you're doing this is for your element superhero project, you'll have to draw where you illustrate your hero or villain. There'll have to be a picture of a drawn Bohr model completed just like this for your element. So I'm sorry, if you had picked an element that has quite a few electrons, you will still have to illustrate all of them. If you did hydrogen, you lucked out. You just have 1 electron to draw. Okay, last part of this video. So valence electrons. You're thinking, what are valence electrons? Those are electrons, and I'd want you to write this down too. Actually, you don't need to, it's right here. These are the electrons in the last shell. Thinking, which ones are those? Remember, the last shell for aluminum happens to be right here, this outer shell here. So how many valence electrons are there in its outer shell? You're thinking, oh, it has 1, 2, 3. Aluminum has 3 valence electrons. That's important in determining how elements interact with one another. Hey, you can think of valence electrons being the handshake of an element as they come into contact with others in nature. Now, if they have a full outer shell, if they've used up, for example, if aluminum happened to have had 8 electrons here, it would have had a completed outer shell, which would make it a much more stubborn element to deal with when interacting with others, which we'll get to when we get to Lewis dot diagrams for the next video. Thanks, folks.